Hello class, today we are doing the final culmination of everything in the polynomial unit, and that is finding all zeros. So we're going to take a polynomial and by the end of this lesson be able to find all of its zeros, aka solutions, aka x-intercepts, aka roots, and we're also going to look at the polynomial and be able to fully factor it. So before we begin, we're going to start with a little warm-up. So take a look at the top of this page. It says consider a polynomial function. What's its degree? What does it tell us about the number of solutions? And to list all of its possible rational roots. So I'm going to stop it, or you should stop it now and complete A through C. All right, welcome back with your warm-up. So what degree is the polynomial? Remember, the degree is the highest exponent. Degree is 3. What does that tell us about the number of solutions? Well, the degree tells us the number of solutions. So that means that we are going to have 3 solutions, or 3 zeros, or 3 roots, or 3 x-intercepts. Well, maybe on the x-intercepts part, because we'll talk about that. And then to list all the possible roots. So remember, you have that p, you have that q. P is the constant, 42. Q is that the lead coefficient, which is 1. And then you do P over Q. So all the factors of 42 over all the factors of 1. Luckily, all the factors of 1, don't forget we have plus or minuses the whole time, is just 1. So 42 is 42 and 1 and 2 and 21 and 3 and 14 and 6 and 7. So again, because it's only 1 on the bottom, we do 42 divided by 1, 1 divided by 1, 2 divided by 1, and it's all ends up just being these numbers. So your PRRs are all of these. Now remember, PRRs are just the possible rational roots. So you're narrowing it down. Possible rational roots is a kind of archaic concept because back then, people needed to know which numbers to guess and check to use the remainder theorem to figure out which ones are zeros. Well, we don't live in the Stone Age anymore. So other than the fact that you need to know possible rational roots for pre-calc, we are going to kind of bypass the possible rational roots and the guessing and checking and use our graphing utility of Desmos to carry on with that part of this. So that's what we're going to lead into today is given a polynomial, so this is the same one we're working with, we're going to be able to factor the polynomial completely and determine all rational zeros. We're going to take out the word rational and we're just going to jump to the chase and just do all the zeros. Now, in order to do this, we are going to follow this steps/checklist. So don't leave home without this. This is the most important thing you have right now. This is what you're going to follow step by step and make sure it gets you the end results. There's a reason why we call it a checklist instead of steps. And the reason why I called it a checklist this time is it is possible that you don't have to do some of the bottom things if you've already found what you need from the top. And we'll see some examples where that really explains. So just note that I am going to be jumping back and forth from this checklist. Hopefully you have this checklist right next to you. So the first thing that we must do is determine how many zeros are we locating. So we're going to start by setting up our answer. That's weird. We're starting the problem by setting up the answer. But that's fine. So I always put the answers off to the side so then I can work under the problem. So if we're starting, we're going to start by setting it up like this. So we need all of our zeros listed. So x equals, do we know how many zeros to find in this? Yes, we do, because the degree tells us how many solutions we're going to have. So in this case, we should have 3 solutions. So I always write x equals and in 3 blank spots because I know by the end of the problem, I need 3 solutions. So I need to fill in each of these spots. Then we're also going to be listing factored form, right? Because we've got to factor the polynomial completely. So there's a 2-part answer. So we have our zeros, and then we also have to write our factored form. So I always start with my answer column and then work from there. Step/checklist number 2 says graph on Desmos and list all the zeros we can see after x equals and their corresponding factors. Note, do not list long decimals. So we're only looking for exact numbers or things like a half or 3/2 or maybe 1/4. We're not looking for 0.3, 3, or well, we could even do that to 1/3. We're not looking for those repeating decimals because we're going to find them elsewhere. So we are going to pull up that graph on Desmos. Luckily, I already plugged it in. See it right here. And we're going to identify all of the solid numbers x-intercepts. So here, lovely for Desmos, if you click on it, it actually tells you exactly what it is. And we have a -3, a 2, and a 7. So we are going to list those after the x equals. So we had a -2, a 3, and a 7. And then as the checklist states, we're also going to list their corresponding factors. So under factor form for -2, that means it's an x plus 2. For 3, it's an x minus 3. And for 7, it's an x plus 7. Now, note that there's still steps 3, 4, and 5 in our checklist, but we are not going to have to go any further because at the beginning of the problem, we said there should be 3 solutions. 1, 2, 3. Each solution has a corresponding factor. So we're done. We don't need to do any more math because we did exactly what it asked. We found all of its zeros and we fully factored it. And we know we fully factor it because if we do x times x times x, what do we end up with? We end up with an x third. So we did the rest of the multiplication there, the rest of the foiling. We should come out to this in standard form. So again, we have 3 factors. We have 3 solutions. That's all we needed. We can stop. Now, of course, don't think the rest of this page is that easy because there are 3, 4, and 5 for a reason. And there's more problems that we need to do that will go into that. And it will have a lot more math processes involved. So now we are going to flip the page, but make sure you keep this step checklist close by. And we're going to look at more problems. We're going to look at number 1. So for number 1, we have our polynomial expression. And the first step is to write x equals and how many solutions we need to get out of this. Well, this is x to the 4th. So that means we need 4 solutions in the end. Which also means to be fully factored, I'm just going to now abbreviate that FF. We're going to make sure each one has a corresponding factor. Step 2 on the checklist is now to go to Desmos and find what x-intercepts we can actually see. So again, I already did this. And this is what pops up when I type this in. So we're going to click and we see an x-intercept here and an x-intercept here, -1 and 1. So I'm going to take -1 and I'm going to put it right here. And I'm going to take 1 and I'm going to put it right there. I'm going to write their corresponding factors. Why am I writing their corresponding factors? Because it says to write it in step 2 as well. So for the -1, that's going to be an x plus 1. Remember, they're opposite. For the positive one, I'm going to do an x minus 1. So currently I only have 2 zeros and I only have 2 factors, but I need 4. So that means I've expanded the graph as much as I could, found what I could out of it. So I need to go to 3. Step 3 says now I must synthetically divide with those found zeros, that 1 and the -1, until we have used them all and our highest exponent is 2. So that means we're synthetically dividing. If we are synthetically dividing, we check the degree is 4. We need to check the order. Well, we go 4 straight to 2. So that means the order is incorrect. That means we need to fill in a 0x to the third because that term was missing. It's really important we do that because that changes the coefficients we're going to use for synthetic division. Now, it said to use the zeros we found. So here's 1 0 we found. Remember, zeros go in the box. Opposite of factors go in the box. So in this case, the straight 0 is -1. So for synthetic division, I'm going to put -1 in the box. Then line up my coefficients, 1, 0, -2, and 1. And I'm going to synthetically divide. So I have 1. 1 times -1 is -1. 0 plus -1 is -1. -1 times -1 is 1. Minus a 2 is a -1. Oh no, looks like I messed up because the order is also missing an x. So I made a common mistake that a lot of you guys will. And I needed to add in another 0 in my coefficients. So -1 times -1 is a +1, which makes this +1. I could just fix that little flub I made. And then this is -1, making the 0 in the remainder spot. Remember, we need the 0 in the remainder spot. The 0 in the remainder spot indicates that -1 is indeed a solution to this problem, but we already knew that. So if you're getting 0 in this box, that means something went wrong. All right, we are going to note, though, that this was the 4th power. So then this brings it down to the 3rd. So that's 1x cubed minus 1x squared minus 1x plus 1. But the steps on the checklist said we don't stop synthetically dividing until our highest exponent is 2. And we have to use all the zeros we found. So we used -1, so now we're going to use 1. We're going to use 1, but we're going to use these coefficients up here because we broke it down already. So we're going to use 1, -1, -1, 1. Yeah, that's a lot of ones. So now I have 1 brought down, 1, 0, 0 times 1 is 0. So that's a -1. -1 times 1 is -1. Again, 0 in the remainder box. You should be getting that all the time. This was to the 3rd, so when I go to rewrite this, it's going to be x squared. I don't have to rewrite that 0, minus 1. All right, so we're at squared. Highest exponent is 2. We can move on to step 4. So 4 says solve by the quadratic formula or factoring if possible. So I have a quadratic. Quadratic is x squared minus 1. I can solve this by factoring. It is a difference of perfect squares because 1 is a perfect square. There's my difference and there's 1. So I'm factoring this to be x plus 1, x minus 1. Now, step 5 says go back and add the zeros you got from solving and find the corresponding factors. So remember, I'm not done solving here. I just factored this. This means that from this equation, I got x equals -1 and 1. So I got -1 and 1 from these. I am now going to go put them in my list. Yes, I happen to have them before, but those were different -1s and 1s. These -1 and 1s came from here, which means they have to have factors as well. Now, I know that I'm done. I can box my answer because I needed 4. 1, 2, 3, 4. Each one has a corresponding factor that I got it from. So I am finished. All right, let's look at number 2. Again, these problems will range on how they're solved and go crazy at some point. So we need to practice a lot. So looking at number 2, I want you to pause the video and you try following your checklist and solving this. And then unpause when you come back. All right, so you're back. Hopefully this worked out fine. You followed the steps. So you looked at number 2, you wrote x equals, you saw third degree, so you knew 1, 2, 3. You wrote down factored form so you can start listing those factors. Step 2 said take this and put it in your Desmos graphing calculator. Here's the graph that I got from that. Here's 1, 2, and 3 x-intercepts, -2, -1, and 1. -2, -1, and 1. You wrote down their corresponding factors, x plus 2, x plus 1, x minus 1. You said, hey, I needed 3. I have 3. Everyone has a corresponding factor. I don't have to go further on that checklist. And you're done. See, sometimes they're really easy. Sometimes they're not. In fact, we're going to get even harder with number 3. All right, so number 3. We're going to do this all together. We're going to start with step 1. We're going to look at the polynomial. We're going to say, that's x to the 4th. I need 4 solutions. And then I write factored form. I'm just going to put a little divide on this problem like you guys should, so we know the difference between the work. Step 2 is go to Desmos, type this equation in, and look at the x-intercepts that you can use. Good thing I pre-graphed this. This speeds up the process. So here's the graph. Here's an x-intercept I can use. -4, so I'm going to write that down. Here's another one, 1. So I have -4 and 1, so corresponding is x plus 4 and x minus 1. Now here's the issue. There is 2 zeros that I have yet to find, and I can't look any further on the graph. So step 3 says I have to synthetically divide with the zeros I have until I'm down to a quadratic. So I'm going to use -4 first. First, I'm going to check the degrees 4. And note 4, 3, 2, 1. Constant order is great. So I can start my synthetic division. -4 in the box. Remember, I'm putting the 0 in the box. 1, 3, -3, 3, -4. Doing all my multiplying and adding down. I bring the 1 down, -4, -1. At this point, synthetic division should be a breeze for you. I have a 1. I have a -1. 0 in the box. Like I said, you should get 0 in that box. The problem is this started as a 4th, so that means I am only brought it down to a cube. But I want it down to a quadratic, so now I'm going to use my cubic polynomial here with the second 0 that I found being 1. Again, a lot of 1s. And I'm going to synthetically divide again. 1, 1, 0, 0, 1. 1 times 1 is 1, and 0 in the box. Rewrite this equation as x squared plus 0x plus 1. I forget step 3 because we only did it once. Okay, so step 3 says synthetically divide. Okay, good. 4, solve quadratic formula or by factoring if possible. Well, x squared plus 1 is not a difference of squares. It's not factorable. So that means, what do I have to use? I have to use not factorable. I have to use the good old quadratic formula. Dun, dun, dun. So remember, for quadratic formula, I am writing down a equals b equals c equals b squared equals 4ac equals. A is 1, b is 0, c is 1, b squared is 0, 4ac is 4 times 1, which is 4. So I have x equals negative b, which is 0, plus or minus the square root of b, which is 0, minus 4ac, which is minus 4, all over 2a, which is 2. Got a lot of zeros in there, so let's rewrite it so I can see that the square root of negative 4, that's going to be an I, so I root 4 over 2. We need to keep reducing. Why do we need to reduce? Because the square root of 4 is, in fact, 2. So that becomes a plus or minus 2i over 2. Oh, I see a 2 on top. I see a 2 on bottom. So that means x equals plus or minus. Only thing that survived was I. So that means x equals a positive I. Boom. And x equals a negative I. Boom. Okay, so I have my 4 solutions, but I don't have my 4 corresponding factors. So if you note this star right here, it says for 5, go back and add the zeros you got from solving and their corresponding factors. If you did quadratic formula and you got answers with radicals and imaginaries, the 2 conjugates factor is the quadratic expression you started with for the quadratic formula. So all that's saying is that from I and I, its factor is this right here, the x squared plus 1. And because that was an x squared, it produced 1, 2 zeros out of it. And now we're done. Much longer. I told you, they're not all a walk in the park. So now we're going to look at number 4. And you're going to start off number 4. I want you to set it up with the x equals and find the rational zeros from the graph. All right, you're back. So I hope you wrote x equals and 3 blanks because there should be 3 and then you wrote factored form. I hope you went to the graph. Boop, boop, boop. You plugged it in correctly. And where did I put this graph? I don't even know where I put this graph because I have so many open, but that's okay. You should have went to your graph and you should have found that it only hit 4. You're only saying 4 because when you graphed this, you had other ones, but they were with repeating decimals. So we don't write those down, and we're going to find those actual amounts with the radicals by synthetic division. So because we found x equals 4, that means x minus 4 is a factor. We're going to go on to step 3. That says synthetically divide with this in the box. We can't synthetically divide until we check the order. 3, 2, 1, constant. Order is good. So I can set up my synthetic division with 4 in the box. The 0 goes in the box. 1, negative 6, 7, 4. We're going to synthetically divide. We got a 1, we got a 4, we got a negative 2, we got a negative 8, we got a negative 1. We have a negative 4, we got 0 in the box. Remember, I said you should have 0 in the box. This was x cubed, so the ones that we got now should be squared, then x, and minus 1. Remember, the next step says we're going to take that quadratic and we are going to factor if possible, if not do quadratic formula. Looking at this, I can't find any factors of negative 1 that give me negative 2. So this is not factorable. So we're going to stop for a moment. You're going to dust off your quadratic formula shoes, and you are going to do the quadratic formula, and then you're going to check back when you have the quadratic formula done and see if you did it correctly. All right, let's see. Did you do it correctly? Well, we had to list A, B, C, B squared, 4AC. A is 1, -2, -1, +4, 4 times 1, -4. X equals a 2 plus or minus the square root of B squared, which is 4, minus a negative, which is plus 4 over 2A, which is 2. Fix the inside of that radical, make that 8. Look at it, say, hey, 8 can be reduced to 4 times 2. So since that's 4 times 2, the square root of 4 brings a 2 out, leaves a 2 in, still has the 2 in the bottom. Remember, we can reduce all of these if we can. 1, 2, 3. Notice how I'm not touching under the radical. You can't change under the radical. So this ends up being 2 divided by 2, which is 1 plus or minus. And then this is a 1 root 2, but instead of writing the 1 root 2, we're just going to write the root 2. So out of this, we have 2 answers. We have 1 plus the square root of 2, and we have 1 minus the square root of 2. We have our 3 solutions, but note that we don't have the factors to correspond. We did the quadratic formula and got irrationals. So the factor that got us these 2 is what we did before the quadratic formula, which is x squared minus 2x minus 1. 3 solutions, corresponding factors. Whew, this is fun. It's really long. I told you, I always consider these commitment problems. You really have to stay committed to keep on going. We're going to do 5 and 6, guys, so we're going to keep chugging along. So number 5, we look at it, and we first have to figure out how many zeros. 1, 2, 3, 4. I got that from the degree, which means then I have my factored form. If you guys find that you don't have enough room on this piece of paper, feel free to use scrap paper at any time. So now, how many zeros did you find on the graph? So go graph this. This is the graph of it. Uh-oh. I only found 1. I only found 1 rational zero, so that's the answer is 2. I put 2 here. X minus 2 is its corresponding factor. Means I got a long way to go because I need 3 more. So we follow the steps and we do synthetic division. We have to make sure it's in the right order. Is it in the right order? 4, 3, 2, 1, constant. It is. I'm putting 2 in the box. So 1, -6, 29, -76, 68. Synthetically dividing these. So 1, 2, yeah, like 1, 2, -4, -8, 21, 42, -34. These numbers stink. Make sure you check these with a calculator. 0 in the box. Good. I know I did it right. But remember, these are starting at the third. And I am told not to stop until I get them squared. But we have a problem. So what do we do now? Because we're not at squared where we're told to stop, but we seem to be out of zeros. Well, we have to recall that in that graphing lab activity, we talked about how imaginary numbers and irrational numbers come in pairs. But we have 3 left. So that means if they come in pairs, at least 2 of them are taken. But that means we're not going to find this other one. So the only thing left that this one could be is a multiplicity. Remember, multiplicity means this number twice. So we're going to use 2 again. We're going to use 2 again in synthetic division with the 1, -4, 21, and -34. And I'll prove to you that the multiplicity is legit because we're going to get 0 in the box. 1, 2, -2, -4, 17, 34, 0 in the box. See? 0 in the box. That means it was another 2. So we're going to list the another 2. And we're going to list its factor again. And now we're back at a quadratic. This is good. We feel safe in this area now because this is where we should be in order to execute step 4. Is this factorable? Well, I need factors of 17 that give me -2. It's not factorable. So what do I need to do? I need to do the quadratic formula. So you guys are going to stop, do the quadratic formula, check back in when you do the quadratic formula and see if you got the remaining zeros. All right, hopefully you're back and this is what you did. Hope you did A equals B equals C equals B squared equals 4AC equals, and you did A is 1, -2, 17, 4, and 68. So then when you get to fill it in, it's x equals 2 plus or minus the square root of 4 minus 68 all over 2a, which is just 2. You go to reduce by doing 4 minus 68. 4 minus 68 is -64 over 2. You see that it's a negative in the radical, so you're going to take it out and you're going to put an I. I'm going to put the I here and just scribble out the negative. Are you all okay with that? I hope so. Well, we then notice that the square root of 64 is 8. So x equals 2 plus or minus 8i over 2. 2 and 2 and 2 and 8, they're all good to be reduced. So I have x equals 1 plus or minus 4i. Remember, there's 2 answers there. There's a 1 plus 4i, and there's a 1 minus 4i. 1, 2, 3, 4 solutions. I am done with solutions. But 1 plus 4i and 1 minus 4i needs a corresponding factor. Because I did quadratic formula and I got imaginary conjugates, I know that the corresponding factor for this is what I started the quadratic formula out with. So I have to write it here. X squared minus 2x plus 17. Yes, I'm running out of space. I know this is the final answer, 1, 2, 3, 4 answers. And then we make sure if we multiplied all the x's, we could also get x to the 4th like we have up here. And we have an x squared. That's all 1, 2, 3, 4 x's, which even out there. So we know we're done. Here's my last example. And I know this was a long one. I said these are commitment problems. It's number 6. Number 6 is actually really cool. And you'll see why in a second. So number 6, there's x to the 3rd. We should have 3 answers. And in the factored form. So we take this, we type this into Desmos. We look at the graph. We see it only hits one x-intercept. That one x-intercept is 2. So we're going to write 2 down, and we're going to do an x minus 2 as its corresponding factor. We're going to do synthetic division, just like we've been. So 2 in the box. The order is 3, 2, 1, nothing. So that's good. Order's good. -1, 6, -12, and 8. We synthetically divide. -1, -2. That's a 4. That's an 8. That's a -4. That's a -8, 0. We know this is a quadratic, which is -x squared plus 4x minus 4. This is really wonky, so I'm just going to put it in the quadratic formula. So I put in the quadratic formula. I have an a, a b, a c, a b squared, a 4ac, -1, 4, -4, 16, 16. So x equals -4 plus or minus 16 minus 16 is 0 over -2. So this goes away, and I'm just left with -4 divided by 2, which is a +2. That's weird because I already got it here. Oh, wait, when we do this, remember, we're finding new zeros. So this must be a new 0. So that must go here, which means another x minus 2. That's odd. Because I need 3. And I know that imaginaries and radicals come in pairs, so this can't be imaginal or radical. That means it must be a rational number. So the only other rational number that I do must be another 2, which means it's another x minus 2. I have 3. That's weird that they're all the same, but it's fine because 2 can have a multiplicity of 3. It is perfectly fine. So that was a wonky one. Here we have 3, we're good to go. So some things to note. These are really long problems. You have to stay committed. Don't look away when you start one of these. Don't go on your phone. Don't have a conversation. Finish this out fully or else you will get lost in your steps. You have to keep up with the steps in the checklist. Don't go off beat. Follow them. They get you the answer. Stop once you do get all your solutions. You don't need to go further if you do have them. And also, there's so many different types of these problems, as you can see, with different results and different answers and different processes, where we're factoring some, we're quadratic formulas, some we are just looking at the graph for some. But remember, stick to that checklist and just keep practicing, because practicing exposes you to all the different types you can see. All right, so that's it for this lesson. Sorry it was super long. This is the longest lesson of the year. This is the longest process of the year. So just know that after this, it gets better, but we do have to work with this for the remaining of December. All right, guys, have a good one.